My name is Edward Washrop, the tutor in Edward's Academy. This evening, I want to continue the introductory dimension of panel data regression. We want to dwell on the variations in the panel data estimation procedures. We have three dimensions or three classifications or categories of variations in panel data regression. The first is the overall variation, the second is between variation, the third is within variation. When we refer to overall variation, we are referring to the variation over time and individual. Remember, in panel data, we have time, which is the scope of the period of study, and the individual, which has to do with the country or the firms. Then between variation measures variation between individual countries, while within variation measures variation in the individuals over time, that the variation of the individual countries over a period of time. So these are the three dimensions of variability or variations in panel data regression that we are going to dwell on. But it's also expected that we look at critical dimensions or the mathematical area or composition of the dimensions of variability we have talked about. T in panel data econometrics refers to time. I refers to cross section, while X refers to variable. Then individual means is expressed as shown here. The overall mean is expressed as X. The overall variances up to the within variances or variations are all as expressed in these computations or this equation. But basically, there's something I want us to look at, which has to do with the pool group or the pool model. So let's look at the pool model, individual specific model, then we'll now proceed to the fixed effects, random effect, and the Horseman test respectively. These are all estimation procedures in panel data that we are going to be exposed to as this class proceeds. The first is the pool model. The pool model, it specifies or it contains estimation that has to pool all the individual components or cross-section into one dataset. As explained here, it specifies its constant coefficient, which is the usual assumption of the cross-sectional data. It's not a robust model in panel data because it gives a biased result. So the pool model, according to what we know, is not a comprehensive estimation procedure because of some biasness inherent in it. And this is not a realistic model because the pool model assumes that all countries shares one constant variable. So in the pool model, if you are working with panel data that has to do with Nigeria, Ghana, Burkina Faso, and some other African countries, applying the pool model actually believe that there is no heterogeneous difference among these countries as so mentioned. And in such a situation, you and I know that in reality, there are too many heterogeneities across these countries I just made mention of. So the pool model has its limitations, but mathematically it's expressed as shown here. Then the individual specific model, we assume that there are unobserved heterogeneity across individuals captured by the constant alpha 1. Unobserved heterogeneity means unobserved qualitative characteristics of the country. So in the individual specific model, the unobserved heterogeneity will be captured with the acronym alpha 1, but in the pool model we have alpha 0, which is constant, beta 1, and the explanatory variable. Then the next dimension of panel data I want us to look at is the fixed effect model. The fixed effects model allows those individual specific effects to be correlated with the regressors. Example, it allows S1 variable to be correlated with other characteristics or variables in the model. It also allows alpha 1 to be the intercept. Here we have different constants, thus this model allows separate constants unlike pool model that has only one constant. So basically in the fixed effects model, we have more than one constant, whereas in the pool model we had only one constant alpha 0. Then we also have another dimension of panel data we call the random effects model. And this assumes that the individual specific effects are distributed independently to the regressor without the constants of the regressor. So in the random effect model, we have an equation expressed as this. And it assumes that the individual effects or individual characteristics of the variable are distributed independently to the regressors. And this is as expressed as this. Then we look at the row. The row in the fixed effects model or the random effect model as expressed can actually mean or what we have expressed previously. It is an intercept correlation of the error term and the fraction of the variance in the error term due to the individual specific effects. And the row approaches 1 if the individual effects dominate the error term. And that will actually be known as the idiosyncratic element. So basically, the fixed effects and the random effects are critical estimation approach in the panel data econometrics, but they are all more robust than the pool model, because the pool model has some biases in it, and the pool fixed and random effects are somehow better than the pool model. But deciding the appropriate model among the pool and the random effects, or among the fixed and the individual specific model, requires a knowledge of what they call the Horstman text. A knowledge of what they call the Horstman text. The Horstman text is a text that enables researchers to actually decide which of the model or which of the models seems to be the best model. The Horstman text enables us to know if we can use the random effects or the fixed effects. Basically, we begin or start using the pool effects before the decision or outcome from the Horstman text. The Horstman text estimation is more efficient in panel data because it gives us an insight to choose the most appropriate model to be adopted. However, it can be adopted in time-varying regressions. And the decision rules or the rule of thumb of the Horstman test are as specified below. If the parameter of the Horstman test, which is the probability value of the Horstman result, is insignificant, then random effects is the best to be adopted. On the contrary, if the Horstman test is significant, then the fixed effects is the best to be adopted. Recall that the Horstman test is a chi-square distributed output with the degree of freedom that is equal to the number of observations to the time-varying regression. So basically, we actually will decide which of the estimation procedure is appropriate as we proceed further to conduct a panel data using the fixed effects, the random effects, the pool, and individual specific units. But before we proceed further, it will be necessary that we look at the basic properties of estimators in the panel data regression. First, we have consistency. And this word consistency, as used in classical least square assumptions, is also applicable at this context because it means that the distribution of the parameter estimate B collapse on B as n becomes large. And if estimation is consistent, it's more appropriate that we look at it that it is reliable over time. And a consistent parameter is a parameter that can be relied upon. And another characteristics of a good property or estimator is efficiency. And it is established when the minimum variance in the relationship is established relative to the specific classes of the estimator. So basically, these two characteristics are actually found in panel data estimation or analysis, and we need to work on it whenever we are looking at or we are working on estimation in the panel data regression. The model building for panel data is actually where we are going to wrap up today's class, because we are going to look at how models are being built in the panel data. Once we are able to look at that, in our next class we are going to consider an example using the e-views. We are going to look at two statistical parameters or packages as we proceed further in this panel data estimation class. We are going to use the e-views to estimate linear regressions, whereas when we go to dynamic panel data regressions such as the GMM and host of other sophisticated estimation approach, we are going to use this data. So basically, building models in panel data requires an intuition of how panel data estimation are supposed to be. Recall in my previous video, I told us the panel data is a combination of time series and cross-sectional data. And in panel data, we have the pool OLS estimators. And this is both within and between variables to estimate its parameter. It stocks the data over I and T. I is cross-section and T is time period, into one long regression with NT observation, estimating it with the OLS estimate. Then the pool estimation is expressed as this. Y underscore IT is a function of alpha 0, alpha plus beta 1, X underscore IT as expressed here. If you look at this equation, you will observe that we have a constant here, and we also have other dimensions of it at this other area, including the error term. So this can actually be expressed as this if you move further. Then note, if the true model is a pool model and the regressors are uncorrelated with the error term, the pool OLS regressors are consistent. If the model is fixed effects, the pool OL model is inconsistent. This means we need to get panel OLS error correction mechanisms. So basically, the random effect model is expressed as this, while the fixed effects model is expressed as previously shown. So basically, this is how panel data are built, or panel data models rather are built in econometrics. But one thing is clear in panel data econometrics model building: the IT represents cross-sectional time period. So IT will actually need to appear in all of your variables to enable it to be known as the panel data. Then the issue of double constants and individual heterogeneity as expressed here is actually what the reader need to critically look at and try to see if you can get perfection. Thank you for listening and watching this introductory dimension of my panel data study. In my next class, I will begin with estimating some panel data approaches using the e-views and this data. Thank you and God bless you.